Hi, welcome to my channel, JaberTime. Today we're going to go over rational functions example given up here, and the focus will be on slant asymptote. It's not a vertical asymptote, it's not a horizontal asymptote, it's a line with a slope different than 0 or undefined. Let's get started. Graph the rational function x minus 3 to the second over x minus 4. To get started, I'm gonna stay focused now on the denominator. So if x minus 4, the denominator, equal to 0, that will give me x equals 4. So we want to avoid x equals 4 because that's going to cause the denominator equal to 0, which again is going to make the rational function undefined. We cannot divide by 0. So we do have a vertical asymptote at x equals 4 that causes the denominator to be 0. While we are into it, let's talk about the domain. So the domain will be all real numbers except 4 because that's a vertical asymptote. The graph is going to be separated part to the right, part to the left of the vertical asymptote. We could write this as interval notation, which says the following. The domain will be from negative infinity to 4, not including 4 as open parentheses, union from 4 to infinity, also not including 4. So pretty much is everything except 4. That's how we read this. Let's talk about the x-intercept and the y-intercept. For the x-intercept, we usually let y equal 0 because when you cross the x-axis, given y equals 0, usually it's not written as given to you, but it should be known as when you cross the x-axis, your y equals 0, and when you cross the y-axis, your x should be known as given to be 0. For this right here, we're gonna let y equal 0. That means the left-hand side, in short, we call it y equals 0, as you could see. Well, to get 0 from a fraction, that comes from the numerator, which means this x minus 3 to the second should be 0. Solving for x, that should be 3. So we have an x-intercept at x equals 3, which is the 0 of the numerator. Let's look at the y-intercept. For the y-intercept, we're going to let x equal 0 as I just mentioned a minute ago. Well, that is just going to take 2 steps to plug in x equals 0 in the equation, or the function, I mean. 0 minus 3 to the second will be minus 3 to the second, which will be positive 9 over negative 4. We kind of don't like the negative to stay down. It's not wrong, but let's put it outside. And without reaching out to the calculator, how many 4s inside 9? There is 2 4s and 1 remainder out of 4, or 1/4. At the decimal point, because we're going to be graphing, negative 2.25. That's my y-intercept. We're going to summarize everything here when we get to the graph. There is more into this problem, but I don't want to squeeze everything on one slide. So that's so far the vertical asymptote, the domain, which kind of relates to the vertical asymptote quickly. And we talked about the x-intercept and the y-intercept. So the y-intercept right here will be when y equal negative 2.25. We talked about the vertical asymptote. Let's look at the horizontal asymptote. For the horizontal asymptote, we have the following case. In this case, we have usually 3 cases, but let's focus on this case that belongs to this one. If the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote because the graph is going to keep growing. In this case, to apply this case right here for this problem, we could multiply the top part and see it as an expanded form. Notice that I'm highlighting the exponents, the highest exponents for both the numerator and the denominator, which is going to lead me to the degree. So the degree of the numerator is 2. And the degree for the denominator is 1. And here it says the degree of the numerator is greater than the degree of the denominator, which is true. 2 is greater than 1. Which means if you go to infinity, the graph is going to keep growing. It's not going to reach a limit as a horizontal asymptote. So we say there is none. There is no horizontal asymptote. Now we come to the main part. The main part is the slant asymptote. And how does it happen? Here we go. Slant asymptote. We're going to do long division. We're going to do synthetic division. And we're going to make a note out of this page right here. For the slant asymptote, a rational function like this one here has a slant, or sometimes called oblique asymptote, if the degree of the numerator is 1 more than the degree of the denominator. We talked about the degree a few minutes ago. The degree is 2 here, and the degree is 1 here, and that goes with this comment. So let's do the long division and see what happens. To divide, we're going to take the leading term, x to the second, divided by the leading term, x, and we get 1x. We put 1x on top of the 6x right here, and we multiply x times x and x times minus 4, which is going to go here as x to the second minus 4x. We change signs and we call it add instead of calling it subtract. Here we go. So we multiply and we change signs and we add. Well, this cancels, and what's interesting is it always cancels. If it doesn't cancel, something is happening right here. Guaranteed it's going to cancel. On this side, we have negative 6x plus 4x, or add 4x to it, which is minus 2x. So let's put it down. We take the 9, bring it down, and now we have minus 2x plus 9. We do the same process again. We take the leading term, divided by the leading term, meaning take minus 2x, divide by x, I get negative 2. This negative 2 goes up here on top of the 9, and we do multiply and multiply. Negative 2 times x is negative 2x, similar to this. Negative 2 times negative 4, which is positive 8, but we need to change the signs and call it add. So it's gonna show like minus 8 instead of plus 8. One more time. This cancels every single time. Okay? 9 and negative 8 will be 1. Now, if this is too long for you, let's do synthetic division. Synthetic division, you take the numbers, the coefficients, the constants without x's. We put them inside. And this is kind of like x minus a. We put a outside. So if it's x minus 5, we put 5 outside. What do I mean by this? By the way, the long division, I forgot to write this down. So let me show you what I have. Before I jump to the synthetic division, we need to read this and write the answer for the long division, which is the following. So when you divide, we get the answer here. We don't call it answer, we call it quotient. That's x minus 2. We have a remainder of 1 out of x minus 4. Alright? We'll get back to what this means in a minute or two. Let's go back to the synthetic division. I mentioned that the synthetic division is the following. We take the numbers 1, negative 6, and 9. And we put the 4 outside, as if this is x minus 4, we put 4 outside. X minus 5, we'll put 5 outside. X plus 3, we'll put negative 3 outside. Because it's supposed to say x minus negative 3. So, anyway. How do we do it? We bring the 1 down. We multiply 1 times 4. We put it right here, which is a 4. We add these two numbers, and that's negative 2. We multiply negative 2 times 4, and it goes right here, which is negative 8. Notice that the numbers that we have, they're just right there. See the negative 8? Do you see the 4? Right here. Let's move on. So negative 2 times 4 is negative 8. 9 and negative 8 will be 1, and that is my remainder. So the quotient will be down here. If we are dividing second degree by first degree, you get first degree. So that is a first degree polynomial. That means this is a constant and this is a first degree. So we read this as 1x minus 2 with the remainder of 1 divided by x minus 4. So that's the same thing. Both ways, the slant asymptote is the quotient, which is x minus 4. I wrote it down here, but I went straight to the synthetic and I did not mention it. The slant asymptote is this right here, y equals x minus 2. And that's what we have. Now, how is that? Why do we call it slant? What's the benefit of long division? What's the concept behind the long division? And writing this as this format. Notice it's two things. I'm using different color because to me this is what we need, and there is a remainder next to it. Here's my note. As x approaches positive and negative infinity, what happens to this fraction? Similar to the 1 over x, the parent function, it's gonna go to 0. When the denominator gets bigger and bigger, the fraction gets smaller and smaller. So eventually, this whole thing will be a value close to x minus 2 plus 0. So as you go to infinity, your f of x will be almost approaching x minus 2. And that is called the slant asymptote. So your graph is going to approach a line that is tilted. It's not horizontal, it's not vertical. It has a slope of 1 and a y-intercept of negative 2. So your f of x will approach what I wrote in red right here, x minus 2. I think that should do it. I know it's kind of lengthy notes, but I'm trying to save you some time from recording and writing this as ahead of the recording to make it clear with colors and neat. Let's go to the graph. We are ready to graph, and I have some comments about the graph. Let's keep going. So a summary of what we did: horizontal asymptote is none. We have x to the second over x. The top part has a higher degree, so it's going to keep growing. That's why it's none. Vertical asymptote comes from the denominator zeros. So in this case, at x equals 4. The x-intercept, that's when we set y equals 0. So we get x equals 3. And the y-intercept, when we plug in here 0 for x, we get positive 9 after you multiply, divide by 0 minus 4, simplify negative 2.25. And the slant asymptote was coming from the long division, and we took it from the quotient because the remainder is going to go to 0. That was y equals x minus 2. Since we do have a vertical asymptote at x equals 4, we mentioned that the domain is all real numbers except 4. So let's graph it. Let's start with the vertical asymptote because we don't have a horizontal asymptote. Vertical asymptote will be at x equals 4 right there. And here we go. That's my vertical asymptote. Let's go with the x-intercept at x equals 3. And here we go. That is my x-intercept. The y-intercept at negative 2.25 down below, right here, somewhere here. And the slant asymptote will have a y-intercept at negative 2 right above this point, and going with a slope of 1 over 1, 1 over 1. So it's going to cross at negative 2 here, cross at 2 here, and it's going to keep going. That is my slant asymptote. So I have a graph right here approaching this vertical line, approaching this slant line, going through these 2 points, and here's the graph. The other piece will be up here, and here we go. And that should do it. It's about 60 minutes, 15 minutes. If I write this on the whiteboard, it's going to take away more than 15 minutes. So that's my plan, just to keep it clean notes. So the reason why I call my videos lecture notes with examples. Thank you. I do have more examples at the same time. After I upload this one, I have more today. So thank you. Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.